So what then becomes the rest of the evidence for the quantal hypothesis? Because clearly in 2013 we accept this hypothesis. This is the original published omega figure transmission electron microscope picture from Heuser and Rees, and you can see the beautiful omega figures that were captured in the stimulated image here. We know from the work of several different laboratories that the very difficult experiment of measuring the amount of transmitter actually released in a single release event is equivalent to the amount that can be isolated from individual vesicles. We know from capacitance measurements of vesicles fusing that we can see stepwise increases in capacitance in parallel to this increase in area expected for the fusion or addition of new membrane to the presynaptic nerve membrane surface. We also see that same stepwise release if we measure the neurotransmitter itself. And measurements have indeed been made of released neurotransmitter. And then we know from dye labeling of recycling synaptic vesicles from that permit real-time visualization of neurotransmitter release, of that vesicle recycling. And Heuser and Rees, besides doing transmission electron microscope images, gave us this freeze fracture technique where they take the neuromuscular junction after it's frozen and they basically crack it so that you can split the two leaflets of the plasma membrane. And this is actually an image looking up into the presynaptic membrane from this is the leaflet that's closest to the cytosol, and we're looking at that leaflet. And you can see these long stripes, which are the neuromuscular junction areas. And in the resting condition, they are lined by little bumps, which are indeed calcium channels. And on either side of those row of calcium channels, one can see under stimulated conditions the invaginated pits where the synaptic vesicles have fused and are in the process of releasing their neurotransmitter. This is just an extraordinary picture. All right, so what about the capacitance measurements? Charge is actually equal to a voltage applied to a capacitance. In other words, we're getting applied voltage to a capacitance and it builds up charge. If we look at how that charge varies over time, we can get a quantity we call current. And current, if one substitutes this, is really the derivative of this capacitance times voltage over time. Now, normally when we do this differentiation, I equals C dV dt, and we don't think of the capacitance itself changing, so we normally exclude the second term. But to make the capacitance measurements here, we have to consider that there are very small changes in membrane capacitance with the fusion of vesicles, so this V dC dt term does become important. And if you use a patch clamp amplifier and feed in sinusoidal waves to it as voltage changes, one can then solve mathematically and get the step changes in capacitance. And so you can see those capacitance measurements here in a stylized but accurate version of a capacitance measurement, where we can see the quite abrupt step changes. These are not single channel openings, but these are rather the vesicles fusing with the plasma membrane and flickering in terms of their ability to stay open before finally staying open for a very long time. And the corresponding measurement of neurotransmitter release done with a carbon fiber electrode, one sees a little trickle of neurotransmitter release, followed by a large bolus of neurotransmitter release once the fusion of the vesicle takes place and the vesicle is fully open. And here's not stylized, but real recordings of the same thing. The capacitance measures show sometimes a very reversible change in capacitance, as if a vesicle fuses but does not stay very long, or in other times where the vesicle fuses and immediately stays, the capacitance goes up to a new level. And so this would be a double fusion event here. Correspondingly, these carbon fiber electrode measurements, which can be made for neurotransmitters which have a charge that can be measured by a carbon fiber. So that mainly is our monoamine neurotransmitters. That's dopamine, serotonin, norepi and epi, histamine, octopamine, anything in that family. You can see a small change in the current when the neurotransmitter, the charged neurotransmitters are released and are sensed by the carbon fiber, and a much larger amplitude of release when the vesicles fully fuse. All right, so what about the timing?